Hello students, welcome to this lecture, One Straight Lines Theory. So in this lecture, we will discuss NCERT section 9.4, 9.4.1 and example 9 and 10. This is disclaimer. So in this lecture, first we will discuss distance of a point from a line. So we will discuss how to find distance of a point from a line. Then we will discuss how to find distance between two parallel lines. Okay. And then we will discuss NCERT example number 9. And then we will discuss NCERT example number 10. So make sure you have your notebooks and pens ready. So let's get started. First, here we will discuss distance of a point from a line. Okay. So suppose you have a line and then you have to find distance from a point x1, y1. So how can you find distance of this point from the line? So here the perpendicular distance is denoted here d of a line ax plus by plus c is equal to 0 from a point x1, y1 is given by d. This is equal to modulus of ax1 plus by1 plus c divided over square root of a square plus b square. Okay, so the distance of a point x1, y1 from line ax plus by plus c, this is basically d equal to modulus value of ax1 plus by1 plus c divided over square root of a square plus b square. So students, first of all, think about this. How would you approach? Okay, how to prove this actually this formula? How to find distance of a point from a line? So think about this for a moment. So first of all, here we let L. Okay, L is basically is a line. Okay, and the equation of this line is basically ax plus by plus c is equal to 0. And whose distance from the point P x1, y1 is d. Okay, so here you can see in this statement we have given the perpendicular distance d of a line ax plus by plus c is equal to 0 from a point x1, y1. Okay, so d is basically perpendicular distance of this line from a point x1, y1. So here we let L such that ax plus by plus c is equal to 0 be a line whose distance from the point P x1, y1 is d, and we draw a perpendicular PM from the point P to the line L. Okay, so we have drawn here perpendicular PM from the point P x1, y1 to the line L such that ax plus by plus c is equal to 0. Okay, so here look at figure 9.14. So here this is the given line. Okay, so here this is L such that ax plus by plus c is equal to 0. So ax plus by plus c equal to 0 is a line, and here we have to find the distance of the line L from a point P x1, y1. So what we have done here, so here first we draw a perpendicular PM from the point P x1, y1 to the line L. Okay, so look this figure very carefully. So if the line meets the x-axis and y-axis at the point Q and R respectively. Okay, so L line meets the x-axis at point Q and the line L meets the y-axis at point R. Then what are the coordinates of the point Q and R? So the coordinates of the point Q is basically minus C over A comma 0. How we get it? So the equation of the line is basically ax plus by plus c equal to 0. Okay. So one x axis, we want to know the y coordinates is always 0. Okay. So if we put the value of y is 0 in equation of the line L, then you will obtain ax plus c equal to 0. And from here, you will obtain the value of x is minus c over a. Okay. And any point on x axis in the form x comma 0. So the coordinates of the point Q are minus c over a comma 0. Okay. And then similarly, if we find the coordinates of R, so how can you find the coordinates of R? Okay. So we know on the y axis, x coordinates is basically 0. Okay. So here you can put the value of x is 0, then you will obtain the value of y is minus c over b. Okay. And any point on y axis in the form 0 comma y. So the coordinates of R are 0 comma minus c over b. Understand? Now, thus the area of the triangle PQR. So here we have triangle PQR, and the area of the triangle PQR is basically, area of triangle PQR is basically half height into base. Okay. And here you can see triangle PQR, height of this triangle is PM. Okay. And the base of the triangle PQR is basically QR. Okay. So area of triangle PQR is equal to 1 by 2 PM into QR. So now from this equation, you can rearrange and then you will get PM. This is equal to basically 2 times area of triangle PQR divided over QR. Okay. So we obtain here PM. PM basically the distance of the line L from a point P x1 comma y1. And here PM we obtain 2 times area of triangle PQR divided over QR. Okay. And note this equation as equation number 1. And we have area of triangle whose vertices are given x1 comma y1, x2 comma y2 and x3 comma y3 is what? So what is the area of the triangle whose vertices are given? So the area of the triangle whose vertices are given x1 comma y1, x2 comma y2 and x3 comma y3 is 1 by 2 modulus value of x1 times y2 minus y3 plus x2 times y3 minus y1 plus x3 times y1 minus y2. Okay. So this is the area of the triangle whose vertices are x1 comma y1, x2 comma y2 and x3 comma y3. So now for finding area of triangle PQR, we are going to use this formula. Okay. And already we have known the coordinates of P, Q and R. Okay. So now area of triangle PQR, this is equal to 1 by 2 modulus value of x1 times 0 plus c by b plus minus c over a times minus c over b minus y1 plus 0 times y1 minus 0. Okay. So this is the area of triangle PQR, and we used here this formula. Okay. As we know the vertices of triangle PQR. Okay. So now if we simplify this, then you will obtain this is equal to 1 by 2 modulus of x1 times c over v plus y1 times c over a plus c square divided over ab. Okay. And then further simplify it. So on taking c common and taking LCM of ab, okay, we get here 2 times area. Okay. We have cross multiply by 2 and we obtain 2 times area of triangle PQR. This is equal to mod of C over AB. modulus of ax1 plus by1 plus c. Okay, so we obtain here this equation 2 times area of triangle PQR. This is equal to modulus of c over AB times ax modulus of ax1 plus by1 plus c. So now look at this figure. So we have to find basically this distance, okay, PM. We have to basically find PM, okay, this distance that is denoted here D. So distance between Q and R. So we can use now distance formula for finding distance between Q and R. Okay, as we know, the vertices of Q and R. So simply we can use these vertices and we can easily find distance between Q and R. So the distance between Q and R is given as QR. This is equal to square root of 0 plus C over A whole square plus C over B minus 0 whole square. Okay, and now simplify it. So if we take common C, okay, and if we take LCM of A square B square, okay, and if we take out from square root, then you will obtain this term modulus of C over AB square root of A square plus B square. Now substituting the values of area of triangle PQR and QR in this equation, PM equal to 2 times area of triangle PQR divided over QR. Okay, so we have already obtained the value of 2 times area of triangle PQR and we obtain the value of QR. Okay, so now we substituting these values in PM equal to 2 times area of triangle PQR divided over QR. Then we get PM, this is basically equal to modulus value of C over AB times modulus of AX1 plus BY1 plus C divided over modulus of C over AB square root of A square plus B square. Okay, after substituting the value of 2 times triangle PQR and QR, we obtain PM, this is equal to modulus of C over AB times modulus of AX1 plus BY1 plus C divided over modulus of C over AB times square root of A square plus B square. Okay, so observe here modulus of C over AB. Okay, this is basically common term in numerator and denominator. So we can here cancel this term. Therefore, we obtain PM, this is equal to modulus value of AX1 plus BY1 plus C divided over square root of A square plus B square. Okay, or we can write D is equal to modulus of AX1 plus BY1 plus C divided over square root of A square plus B square. Thus, the perpendicular distance D of a line AX plus BY plus C is equal to 0 from a point x1 comma y1 is given by small d. This is equal to modulus of AX1 plus BY1 plus C divided over square root of A square plus B square. Okay, so note this formula. So this is the formula of a distance of a point from a line. Okay, so if we have given a point, okay, and if you have given a line, then you can find distance between point and line by using this formula, that is here D equal to modulus of AX1 plus BY1 plus C divided over square root of A square plus B square. So now we will find distance between two parallel lines. So we have studied distance between two perpendicular lines. Okay, we have learned distance between line and a point. Okay, so now we are going to learn distance between two parallel lines. So the distance D between two parallel lines. Okay, we have taken here two parallel lines, y equal to mx plus c1 and y equal to mx plus c2. So y equal to mx plus c1 and y equal to mx plus c2. These two lines are basically parallel line. So the distance D between two parallel lines, y equal to mx plus c1 and y equal to mx plus c2, is given by D is equal to modulus value of c1 minus c2 divided over square root of 1 plus m square. Okay, simple. So we basically take modulus of difference of constant term, okay, and then divided by square root of 1 plus m square. So this is the distance between two parallel lines. So now we will see proof of this formula. Okay, so we know that slopes of two parallel lines are equal. Okay, we already learned about this statement. Okay, if we have two parallel lines, then their slopes are equal, and if their slopes are equal, then the parallel line the lines are parallel. Okay, so we know that slopes of two parallel lines are equal. So therefore, two parallel lines can be taken in the form y equal to mx plus c1, okay, and y equal to mx plus c2. So naming this equation y equal to mx plus c1 as 1 and y equal to mx plus c2 as 2. So here you can see line 1 will intersect x-axis at point A. Okay, and what are coordinates of point A? So here you can see if we put y equal to 0, then you will obtain x is equal to minus c1 over m. Okay, so the coordinates of the point A are minus c1 over m comma 0. Okay, and basically we have to find here this distance. Okay, this distance basically distance between two parallel lines, y equal to mx plus c1 and y equal to mx plus c2. Okay, and here we obtain this coordinates of this point A, that is here minus c1 over m comma 0. So now easily we can find this distance. So we have the perpendicular distance d of a line ax plus by plus c equal to 0 from a point x1 comma y1 is given by this small d equal to modulus of ax1 plus by1 plus c divided over a square plus b square. Okay, so this is the distance of a line ax plus by plus c equal to 0 and from a point x1 comma y1. Okay, and we have already known about this. So now distance between two parallel lines is equal to the length of the perpendicular from point A minus c1 over m comma 0 to the line y equal to mx plus c2. Okay, so if we find the distance of a line y equal to mx plus c2 from a point A minus c1 over m comma 0, then that distance is basically the distance between two parallel lines. So the length of the perpendicular from point A minus c1 over m comma 0 to line y equal to mx plus c2 is what? So what is the length of the perpendicular from the point A to the line y equal to mx plus c2? So the length of the perpendicular from the point A minus c1 over m comma 0 to the line y equal to mx plus c2 is basically modulus of minus m times minus c1 over m plus minus c2 divided over square root of 1 plus m square. Okay, simply we used here this formula d equal to modulus of ax1 plus by1 plus c divided over a square plus b square. Okay, so if we compare this line y equal to mx plus c2 with the general equation of the line ax plus by plus c equal to 0, then you will obtain here x the coefficient of x is basically m and the coefficient of y will be minus 1. Okay, and the constant term here c2. Okay, so if we substitute here the point x1 comma y1, that is here minus c1 over m comma 0 in this formula, then we will obtain the length of the perpendicular from the point A minus c1 over m comma 0 to the line y equal to mx plus c2. This is basically modulus of minus m times minus c1 over m plus minus c2 divided over square root of 1 plus m square. So now simplify it. So if we simplify it, then we will obtain this is equal to modulus of c1 minus c2 divided over square root of 1 plus m square. Okay, so this is the length of the perpendicular from the point A minus c1 over m comma 0 to the line y equal to mx plus c2. So therefore, distance between the lines 1 and 2 is basically small 2. This is equal to modulus of c1 minus c2 divided over square root of 1 plus m square. Okay, so this is the distance between two lines 1 and 2 Okay, that are basically parallel lines. Okay, so the distance between two parallel lines y equal to mx plus c1 and y equal to mx plus c2 is basically small d is equal to modulus of c1 minus c2 divided over square root of 1 plus m square. So distance between two lines is equal to the length of the perpendicular from point A to the line 2. Okay, so therefore distance between the lines 1 and 2 is basically we already calculated. So we obtain here small d, this is equal to modulus of c1 minus c2 divided over square root of 1 plus m square. Thus the distance d between two parallel lines y equal to mx plus c1 and y equal to mx plus c2 is basically small d, this is equal to modulus of c1 minus c2 divided over square root of 1 plus m square. Okay, so this is the formula for distance between two parallel lines. So note this formula. So if lines are given in general form, okay, so we have taken here the equation of the line y equal to mx plus c1 and y equal to mx plus c2. Okay, and if we now take the equation of the line in general form, then here we can take ax plus by plus c1 equal to 0 and ax plus by plus c2 is equal to 0. Okay, and then above formula, okay, this formula will take the form d equal to basically modulus of c1 minus c2 divided over square root of a square plus b square. Okay, so if we have two parallel lines in the form ax plus by plus c1 equal to 0 and ax plus by plus c2 equal to 0, then the distance between these two parallel lines is small d equal to modulus of c1 minus c2 divided over square root of a square plus b square. So write down this formula. This formula is very important formula. So we will use this formula to solve this question. So now let us take an example. So now we will discuss NCERT example number 9. So what we have given in this example, first of all see this. So here we have to find the distance of the point 3 comma minus 5 from the line 3x minus 4y minus 26 is equal to 0. Okay, so basically we have given here a point 3 comma minus 5. Okay, and the equation of the line 3x minus 4y minus 26 is equal to 0, and then we have to find the distance of the point 3 comma minus 5 from the line 3x minus 4y minus 26 is equal to 0. So students, first of all, think about this for a moment. How would you approach this example? So you have 30 seconds to try to solve this question, and then we will provide the solution. Okay, students. So now we will see solution. So we have to find here the distance of the point 3 comma minus 5 from the line 3x minus 4y minus 26 is equal to 0. So given line is here 3x minus 4y minus 26 is equal to 0, and naming this equation as equation number 1. And now comparing equation 1 with the general equation of the line ax plus by plus c equal to 0. Okay, then what we'll obtain here? So then we get a equal to 3, b equal to minus 4 and c equal to minus 26. Okay, so if we compare 3x minus 4y minus 26 equal to 0 with the general equation of the line ax plus by plus c equal to 0, then we get a is 3, b is minus 4 and c is minus 26. And given point is here x1 comma y1, this is equal to 3 comma minus 5. And we know that the perpendicular distance of a line ax plus by plus c equal to 0 from a point x1 comma y1 is given by d equal to modulus of ax1 plus by1 plus c divided over square root of a square plus b square. Okay, so we know this formula, the perpendicular distance of a line ax plus by plus c equal to 0 from a point x1 comma y1. Okay, so now we are going to applying this formula to find the distance of a point 3 comma minus 5 from the line 3x minus 4y minus 26 equal to 0. So therefore the distance of the given point from the given given line is basically d equal to modulus of 3 into 3 plus minus 4 into minus 5 minus 26 divided over square root of 3 square plus minus 4 whole square. Okay, so now calculate it. So if we calculate it, then you will obtain d equal to 3 over 5 unit. Okay, so the distance of the given point from the given line is 3 over 5 unit. Okay, so hence the required distance is 3 over 5 unit. So match with your answer what you have done. So the answer is here basically 3 over 5 unit. So I hope it is clear to all of you. So now let us move on to the next example. So now we will discuss NCERT example 10. So in this example, we have to find the distance between the parallel lines 3x minus 4y plus 7 equal to 0 and 3x minus 4y plus 5 equal to 0. Okay, so we have given basically two parallel lines and then we have to find distance between these two parallel lines. So students, first of all, think about this for a moment. How would you approach? Okay, so calculate the answer of this example first. So you have 30 seconds to try to solve this question. Then we will provide the solution. Okay, now we will see solution. So we have to find here the distance between the parallel lines 3x minus 4y plus 7 equal to 0 and 3x minus 4y plus 5 equal to 0. So now let us see solution. So we know this formula. If lines are given in the general form ax plus by plus c1 equal to 0 and ax plus by plus c2 equal to 0, then the distance between the parallel lines ax plus by plus c1 equal to 0 and ax plus by plus c2 equal to 0 is basically small d equal to modulus of c1 minus c2 divided over square root of a square plus b square. Okay, so first of all, we have to identify the value of C1, C2 and A and B. Okay, so if we obtain the value of A, B and C1 and C2, then easily we can apply this formula and then we will obtain the answer. So let's try to solve this. So given here the parallel lines are 3x minus 4y plus 7 equal to 0 and 3x minus 4y plus 5 equal to 0. Okay, these two parallel lines are given here. And if we compare these two equations with the general form ax plus by plus c1 equal to 0 and ax plus by plus c2 equal to 0, then we will obtain the value of a is 3, b is minus 4, c1 is 7 and c2 is 5. Okay, so therefore the required distance is d equal to modulus of c1 minus c2, that is modulus of 7 minus 5. Okay, square root of a square plus b square, that is square root of 3 square plus minus 4 whole square. Okay, and if we calculate it, then you will obtain d equal to 2 over 5. Okay, so the required distance is basically 2 over 5. Hence the required distance is 2 over 5. So I hope it is clear to all of you. So that's all for today's session. So thank you very much to all of you.